welcome back. Today we're talking about solving systems equations using the elimination method. Now let's take a look at how we're going to do that. So here we have the steps for solving using elimination. We're going to choose a variable to cancel, multiply the entire equation by a constant if needed. We're going to rewrite the system with a new equation and combine the two equations together. Then we're going to substitute the resulting value into either original equation, and that's key. And then we're going to solve for the remaining variable. Now let's put this to practice with example A. So here we are at example A, and it says solve x and y and write your answer as an ordered pair. So we've got a system there of equations, and we've got to make sure that we're going to eliminate them. So we're going to try and get one of the variables by itself. We're going to do that by trying to find a opposite that we can cancel. So we've got x equals 11 plus y and 2x plus y equals 19. So I know that if I move this positive y to the opposite side of my equation, not only will I have x and y on the same side, which I'm going to need to have in order to combine them, but that will also create a negative y that I can combine with the positive y to cancel out. So let's see how that's going to work. So I'm going to go ahead and write my x equals 11 plus y down here so I can start moving things around. So I'm going to move my y to the opposite side. I'm going to do that by subtracting y on both sides. When I do that, I'm going to end up getting x minus y is equal to 11. So now I've got x and y on the same side as 2x plus y. And I've got positive 11 and negative 11, and that's important because these guys are going to be canceling each other out in a moment. So let's go ahead and now write our equations that we have, our new equation. So we've got x minus y is equal to 11 as my top equation, and I've got 2x plus y equals 19 as my bottom equation. So now it's time to combine. So we're going to go ahead and add. So x plus 2x is going to give me 3x. Positive y and negative y are going to cancel, and 11 plus 19 is going to give me 30. So I've got 3x equals 30, and I've got a one-step equation. So I'm going to go ahead and draw my wall, divide both sides by 3, and I get x is equal to 10. So now I've got 10, that's one of the numbers in my ordered pair, but now I need to find y. In order to do that, I can plug that into whichever equation I would like to. Again, you can pick the one that's probably going to be the less work, but you cannot plug it into the new equation we made. So we cannot plug it into this x minus y equals 11. Can't do that, but we can pick either one of our original equations. So I'm going to go ahead and plug it into the top one. So I'm going to have 10 is going to plug in for x equals 11 plus y. So now I've got a one-step equation. I'm going to draw my wall, subtract 11 from both sides. These are going to cancel. I'm going to get negative 1 is equal to y. So that's the other number in my ordered pair. And I'm done with this problem. Now let's take a look at example B. So here in example B, again, I'm going to solve for x and y and write your answer as an ordered pair. So I've got negative 2x minus 9y equals negative 25, and negative 4x minus 9y equals negative 23. So good news, they're already set up so that I've got x's and y's on the same side and constants on the other side, so I don't have to do any arranging. Bad news is nothing will cancel out currently because if I add the negatives together, I'll get negative 6x. If I add the y's together, I'll get negative 18y. So that's not going to work. So I'm going to have to find some number that I can multiply either the top or the bottom by. Now the good news is that I could multiply one of them by the negative 1 to get a positive. So if I multiply my top equation here by negative 1, that's going to result in me getting a positive 2x because negative 1 times negative 2 is going to give me positive 2x. Negative 1 times negative 9, negative times a negative is a positive, so I end up with positive 9y. And then negative 1 times negative 25 is going to give me positive 25y, or minus 25. All right, so now I'm going to bring over my other equation I didn't do anything with, so negative 4x minus 9y is equal to negative 23. So the good news is now I can see that my y's are going to cancel, so I'm going to do that. So 2x and negative 4x added together is going to give me negative 2x. Positive 9y and negative 9y are going to cancel, and then 25 minus 23 is going to give me positive 2. So now it's time to solve my one-step equation, so I'm going to go ahead and draw my wall. I'm going to divide both sides by negative 2. Negative 2 divided by negative 2 is a 1, or 1x, and positive 2 divided by negative 2 is negative 1. So now I've got one of my ordered pairs, which is negative 1. So now again, I can substitute that in, and I can substitute it into either of my equations, but it has to be the original equation. I cannot plug it into this equation here that I invented. So I'm going to have to plug that into I'll plug it into the bottom one this time. So we've got negative 4 times negative 1 minus 9y is going to be equal to negative 23. So now I just need to go and solve my equation. So I get a positive 4 here minus 9y is equal to negative 23. I'm going to go ahead and subtract 4 on both sides. These are going to cancel, leaving me with negative 9y. It's going to be equal to negative 27. Divide both sides by negative 9, and I get y is equal to positive 3. So positive 3 is the other number in my ordered pair, and I've completed this problem. Now let's take a look at example C. Here we are at example C, and it says solve for x and y, and write your answers in an ordered pair. So here we've got 2x minus 3y equals 2, and 5x plus 4y equals 28. So good news, they're already in standard form for me. I have got my x's and y's lined up, so that's great. Bad news is none of them look like they're going to be easy to multiply. It looks like I'm going to have to multiply both equations because, again, I'm trying to find numbers that can be eliminated. So 2 and 5, I could try and figure out how to get that to 10, or I can see that 3 and 4 can be multiplied together to give me 12. And since some of them are already negative and one of them is already positive, that might be the easier way to go. So I'm going to go ahead and multiply the top equation by 4 because I want to make sure that I end up with negative 12 there. So 4 times 2 is going to give me 8x. 4 times negative 3 is going to give me negative 12y. 4 times 2 is again going to give me 8. Then I'm going to do the same thing to the other equation, except this time I'm going to be multiplying by 3 because, again, I want to end up with that negative 12 and positive 12 being added together. So 5x and 3x, 5 times 3 is going to give me 15x. Then I've got 3 times positive 4y, which is going to give me positive 12y. And 3 times 28 is going to give me 84. All right, so now I'm going to go ahead and do my adding and my combining. So I've got 8x and 15x, that's going to give me 23x. 12 negative y and positive 12y are going to cancel. And 8 plus 84 is going to give me 92. So now I've got to follow my one-step equation, so I'm going to draw my wall. I'm going to divide both sides by 23. These are going to cancel, and I'm going to be left with x equals 4. So that's great. I've got one of my ordered pairs, which is 4. One of the numbers in my ordered pair, which is 4. Now I can substitute that back into any equation, but I want to substitute it again into one of my original equations. Since I don't want to deal with 28, I'll substitute it into the top equation. So I've got 2 parentheses 4 minus 3y equals 2. So 2 times 4 is going to give me 8. I'm going to end up with 8 minus 3y is equal to positive 2. Now I'm going to go ahead and solve my equation, so I'm going to subtract 8 from both sides. This is going to leave me with negative 3y. It's going to be equal to negative 6. And my final step there, I'm going to go ahead and divide both sides by negative 3. When I do that, these are going to cancel, and I'm going to be left with y equals positive 2. So 2 is the other number in my ordered pair. So that brings me to the end of this problem. It also brings me to the end of this set of notes. If you like this video, go ahead and throw say thumbs up. If you would love this video, go ahead and throw say sub, and we will catch you in the next one.